So, we're in the middle of this AI revolution, and it's completely rewriting the rules of science. But here's the thing, as artificial intelligence transforms the lab, are we failing our future scientists in the classroom? That's the big question we're digging into today. I mean, just think about it. AI isn't some science fiction idea anymore. It's the engine that's driving new breakthroughs in drug discovery. It's the brain predicting these impossibly complex reactions. And it's literally the hands automating entire experiments. Science is moving at a speed we've never ever seen before, and AI is firmly in the driver's seat. And look, if you want proof this is for real, just follow the money. In 2023 alone, a staggering $25.2 billion was invested in generative AI. Industries aren't just testing the waters here. They are diving in headfirst. The future isn't coming. It's already here, and it is absolutely powered by AI. Which, brings us right back to the heart of the problem. If the actual tools of science are changing this fast, this dramatically, doesn't the training of scientists have to change too? Are we really getting the next generation ready for the labs of tomorrow? Or are we kind of stuck teaching the science of yesterday? So let's talk about how this revolution is really changing things. Because it's not just about learning some new piece of software. This is about a fundamental shift in the scientific mindset itself. It's a whole new way of thinking. And you might be surprised to hear that AI in chemistry, well, it's not exactly new. It actually goes all the way back to 1965 with a project called Dendrol. For decades, it was this slow, steady burn. But then you get to the 2020s and boom, it's a full-on explosion, with generative AI just launching progress into total overdrive. Okay, so this explosion is being fueled by really profound change in how we approach science. For centuries, we've relied on what's called deductive learning. You start with a theory, then you test it with data. Simple enough. But AI completely flips the script. It's a master at inductive learning, sifting through mountains of data to find patterns and propose theories we might never have even dreamed of. We're really moving from a theory-first to a data-first world. So with this massive shift happening, how are universities keeping up? Well, a recent survey of 51 of the top-ranked chemistry programs in the world gives us a pretty fascinating and, frankly, a really crucial reality check. And the results? They're pretty telling. Now, it's great that 38 out of the 51 universities offer some kind of computational course. But here's the catch. When you look for courses specifically on AI or machine learning, that number just plummets to 23. That's less than half. There's already a huge gap forming between the tools people use in the real world and what's actually being taught. And it gets even more interesting when you peel back the layers on those computational courses. The vast majority, they're your traditional computational chemistry or chemoinformatics classes. Only this tiny, tiny little slice focuses on the real game changer, computational thinking. And that's not just about running software. It's the core skill of how you break down a complex problem so a computer can even begin to help solve it. But you know what? All this data reveals a really powerful pattern. The universities that are successfully teaching AI and machine learning, well, they almost all have something in common. A strong, pre-existing foundation in those computational courses. So it seems pretty clear that one really does build on the other. Okay, so we've identified the gap. The big question now is, how do we close it? Well, thankfully, the source material gives us a pretty clear roadmap, and it involves asking some critical questions of the three groups of people who can really make change happen. First up, let's talk to the students. The responsibility isn't just on your university, You need to be asking yourself, what skills are going to make me truly future ready? How can I take charge of my own learning? And maybe most importantly, how do I use these new tools not just to get an answer, but to truly understand the process of finding it? Next, the spotlight is on the instructors. And listen, the challenge is huge. How do you redesign a whole curriculum for a world that's changing by the minute? Are your assignments actually preparing students for the modern workplace? And this is a big one. Are you teaching them the critical thinking skills to know when an AI is wrong, when it's hallucinating and leading them astray? And finally, this goes up to the university leaders. This kind of change has to have support from the very top. Are you giving faculty and students the right training and resources? Is the infrastructure even there? And are you managing this whole transition in a way that supports your academic staff instead of just piling on more and more work? But with all this incredible power comes a profound responsibility. This isn't just a technical challenge, it's a deeply ethical one. We really need a whole new definition of what scientific integrity means in the age of AI. And this is where the conversation really needs to shift.
So much of the talk in education has been this panicked race to figure out how to detect AI use. But what if that's the wrong race entirely? The real challenge isn't about catching students, it's about teaching them how to use these tools ethically and effectively in the first place.
So what does that mean? It means the goal can't be to create AI-proof assignments or to try and ban these tools. Honestly, that's a losing battle, and it leaves students completely unprepared for the real world. No, the real mission here is to build a new culture of academic integrity, one where AI is treated like a powerful collaborator, and its use is transparent, it's acknowledged, and it's ethical.
At the end of the day, it all comes down to the simple, powerful idea right here in this quote. The world is changing, and our ways of teaching have to change with it. Because the relevance of our education and the readiness of our future scientists, well, it all depends on it.